Okay, so we need the first number and the last number. So we say that A0 is 21 and AN is the 4, and we need dividers of both of them. Okay, so dividers of 21 would be 1, 3, 7, and 21. And divisors of 4 would be 1, 2, and 4. Because 3 times 7 gives you 21. 1 times 21 gives you 21. 1 times 4 gives you 4. 2 times 2 gives you 4. Okay? So then what we need to do is we need to find rational numbers. So this could be plus or minus. And we'll put all of the a sub zeros on top. So 1, 3, 7, and 21. And the a sub n's on the bottoms, 1, 2, and 4. So this could be a 1 divided by 1 plus or minus, a 3 divided by 1, a 7 divided by 1, a 2 divided by 1, a 1 divided by 1, or sorry, a 21 divided by 1, or 3 divided by 2, 7 divided by 2, 21 divided by 2, or you can keep on going. Okay, 21 divided by 1, 21 divided by 2, 21 divided by 4. All those plus or minus. If we try negative 3 over 1, okay, so I took a negative, the 3 divided by 1. And if I pulled that out of this right here, so what I need to pull out is x plus 3. So I'm changing this negative to a plus. So I'm essentially dividing out. This is basically what I'm doing. This 4x squared, this entire polynomial divided by x minus 3. Now you can use synthetic division, and what you would get is 4x squared plus 8x plus 7. Okay, now we have 1, 0. That was this right here. So negative 3 is our first 0. We need 2 more because we have a degree of 3, so we should have 3 zeros. So negative 3 is one of our zeros. We need 2 more. Notice how this is a 2. That's going to give us our other 2. So in order to solve this one, find the zeros of this one, it doesn't look like I can factor. So what I'm going to have to use is the quadratic formula. If you use that, that will give you the remaining 2 numbers that you need.